All right, class. This is Mr. Hart. Today we want to go over week two of stars, galaxies in the universe. So, if you remember last time, we talked about how the universe was formed and the Big Bang and its history. This week we talked about groupings of stars. Okay, some of the different features we actually see in the universe and some of the ways we categorize things. So, a lot of the times, the way we categorize the objects we see in the universe is based on the stars, how many stars are in them, how far apart they are, things like that. Okay, so for example, let's look at just our solar system, right? We call it a solar system. It has one star in it. Okay, we call it a star system or something like that. Okay, so there's one star in our solar system. Another grouping is a binary star. So some systems have two stars in them, and they kind of orbit around each other. As you can see from these kind of these tails they have, the paths they've taken. So they kind of spiral around and swirl around. So it's really hard for a planet to exist in this space because the stars are moving so much. But in a binary star system, there's two stars, and they orbit each other. Okay. If we add even more and more stars, okay, we start to get into larger groupings, things like star clusters or an open cluster, for example. So a star cluster is a larger group of stars, usually around hundreds or thousands. So if you kind of see here, there's a bunch of stars. They're not really organized in any way, but they're just kind of nearby. So we call these groupings open clusters. They they're not really associated in any way, but they're close enough and in this kind of open cluster that we categorize them as such. Okay, so hundreds of thousands of stars. If we start to get more and more stars, that gravitational pull gets stronger, and then we get a large globular cluster, is what it's called. So in these groups, we have tens of thousands to hundreds of thousands of stars held tightly together by gravity. Okay, so once the gravity is strong enough, these clusters start to pull in and get stronger and stronger. Okay, you get a large, very large grouping. Okay, so this is a globular cluster. Once we get enough stars, we get our galaxies. So galaxies are the biggest groups of stars that we see, and they have anywhere from a few million to many billions of stars. Okay, so galaxies are just ginormous. Okay, they usually come from these large globular clusters. Okay, but these are pretty much the largest grouping of stars we can see in the universe, and we can tell by usually these spiral or arms around the edge of these galaxies. Okay, so then we watched the simulation on how a galaxy forms, and you can watch it here at this YouTube address. But it's really interesting to see the stars being pulled in together and forming these galaxies from these large clusters. Okay, but there's a couple of different styles of galaxies. Okay, there's spiral galaxies. So spiral galaxies are spinning usually, and they have this rotating disk of stars and dust, and they bulge in the middle. So if you look at this galaxy, for example, you can see this outer ring of dust and this bulge in the center. If you look at this galaxy over here, or sorry, if you see it from the aerial view, same galaxy but from an aerial view, you can see these arms kind of spinning out and rotating from the center. Okay, and if you look at these spiral galaxies, they have lots of gas and dust and young stars. That's because these stars are just nearly forming on the edge of the galaxy. Okay, as they're spiraling in towards the center, they get older and older, right, and they get brighter and brighter. But towards the outer edge, where there's less of a gravitational pull, they are just newly forming. Okay, so spiral galaxies have lots of young stars. Okay, then we have elliptical galaxies. Okay, they're more oval shaped. They're kind of reddish to yellow in color because the stars are older. They're not as bright. They're starting to die down. Okay, usually contain mostly old stars. So these ones usually either form because they didn't have a lot of um, momentum, like in a spiral galaxy when they were first formed, or a spiral galaxy can kind of eventually slow down and form into these elliptical galaxies as they get older. Okay, but these are kind of the older galaxies, the elliptical galaxies. Then we have irregular galaxies, which kind of just don't fit into any category. They're ginormous, so they're big enough to be a galaxy, but they don't have any nice uniform pattern or anything to categorize them with. Okay, so those are the three types of galaxies: spiral, elliptical, and irregular. So if we look at our Milky Way galaxy, okay, which we thought was the universe for a long time, but it's just our galaxy that we're in. Okay, it is actually a spiral galaxy. Okay, but the reason it was called the Milky Way was because it had this kind of white froth that we could see in the sky. Okay, which gives it that term, the Milky Way, this milky, frothy looking gas cloud in the sky at night. Okay, that turns out to be the center of the Milky Way. Okay, what we're seeing is the center, this central beam of the Milky Way. That's that milky froth they were seeing, and that's where we got the name for it. Okay, but if we look at the Milky Way, it's a spiral galaxy. It's about 100,000 light years across, but only 3,000 light years thick. So it's pretty thin, relatively speaking, okay, and very large and rotating disk. So as you can see here, here's our sun. Okay, so if you look at its position relative to the center and the outside, our sun is kind of a medium-aged star in this galaxy. Okay, it's not towards the edge, so it's not young, and it's not towards the center, so it's not old. It's kind of right in the middle, which is nice. It's a medium-aged star, and it won't die for a couple billion years now. So that's good for us as humans. So right in the center, or not right in the center, but right in the middle between old and young of the stars in the Milky Way galaxy. Okay. So after we talked about that, we did a vocabulary review. Okay, you can find that review online, but you should know these terms. Okay, what they mean, some of the differences between them, all those things. Excuse me. All right, so again, that's online if you want to, or if you need to do that assignment. Okay. Then we talked about what else is out in the universe. So besides all these star clusters and groupings and galaxies, okay, we looked at some of the other unique features. Okay, so there's also nebula. Okay, so these are just large clouds of dust. Okay, things that haven't formed in the stars yet, just some of the basic material. Okay, and many stars in the early stages of their formation are in these nebulas. Before they become stars, they kind of form once these nebulas can compress the mass down hard enough to form a star. Okay, and they're about 100 light years across. So, nebula you can think of as kind of like before any star is born, they come out of a nebula. Okay, they're kind of the formations, the creators of stars. Okay, these are actually called the pillars of creation. Okay, that's kind of their nickname, the pillars of creation. This is just one nebula, but they create all the stars we see. And another thing about nebula is they just look cool. Okay, this is the Butterfly Nebula, and as you can see, it was appropriately named from its description and its appearance. This is the Crab Nebula. They're just the coolest things you'll see in astronomy. So if you ever want to find cool pictures in astronomical findings, look up nebula. They always look really cool. But an interesting thing about nebula is we have something called nebular theory, which is the idea that all stars form from some type of nebula material. Okay, so any star that's born eventually or previously came from some type of nebula or some nebula out in the universe. Okay, and you can imagine right when the Big Bang happened, right, for the first 100,000 years, we probably only had nebula. Okay, we didn't have any galaxies or anything that formed yet, so all we just had was this large groupings of dust and material. So all the stars that have formed probably came from nebular material. Okay, so that's nebular theory. Okay, then we talked about some other cool features. So we have things like neutron stars. Okay, these things are very massive. They're only 12 miles in diameter, but they're 1.5 times the mass of the sun. So if you think about this, if you had like a teaspoon of neutron star material, it'd weigh like 200,000 tons or something ridiculous like that. Okay, because these things are just so compressed, all the neutrons are packed together. Okay, it doesn't have any chemical properties, it's just neutrons, but these things are just packed together so strongly that they're just super massive, super dense, and have very strong gravitational fields. So if you had like a teaspoon of neutron star material on your desk, you could have things like orbit it and things like that. So pretty cool, very dense. Always wanted to visit a neutron star one day and see how strong the gravitational pull was. But anyways, then other cool things, we have the black holes, okay, popular in, you know, science fiction and things like that. But if you think about a black hole, it's simply a rip in, I guess you would call it space fabric. Excuse me. And so if something gets massive enough, it can rip the fabric of space, causes this hole. Okay, and there's a lots of things that come from this. Okay, but main thing is just this very strong gravitational pull, and material can orbit around it just like a star. And in most galaxies, actually, there's a black hole at the center. So very strong gravitational pull. Things can't escape once they get in. And again, there's lots of features. There's lots of features of black holes that we can't describe in this podcast. It would just take too long. But look them up if you're interested, because they have some very unique properties. Okay. Then we talked about wormholes. Okay, this is just an artist visualization, but wormholes are also very interesting objects that appear in the universe. The easiest way to think about them is they are bends in space, or connections between bends in space. So if you look at here's the fabric in green. Okay, it kind of bends around, and then it comes up here. This wormhole will connect these two spots. So if there's a large object here that's causing this bend in space, the two objects can actually cause this wormhole to appear, and they'll connect these 2 points in space. So, for example, if we are traveling along this red line, okay, and we move, we just are going straight. We don't realize there's this bend in space, but then we can see this hole, and if we jumped in it, we would actually end up back to where we started, right? So it's that, to us, it would appear like a teleportation device. That's what people usually think of for wormholes, is they are a teleportation device. And they kind of are in a way, but really it's just we're jumping to 2 points in the fabric. Okay? So to us it looks like it's teleportation, but really it's just moving through this tunnel. Okay? But that gives us some cool properties, because we can teleport in our sense. Okay? And also, because this fabric also involves time, we can also go back in the past. So not only will we end up back where we were, but also end up back at what time it was. So really interesting phenomenon. Again, we're still trying to understand more about these things, but the idea is they can teleport us back in time and space. Okay, so really interesting features. I also recommend looking up more about them if you can. But anyways, that's all we talked about in week 2, and let me know if you have any questions, and thank you for watching.